A standard question in arranging alphabets of a word is, in how many ways can the alphabets of Mississippi be arranged? Most of us are aware of the answer, so I'll just tell you the method first. Count the total number of objects: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial. However, we need to do some adjustments to this. M is not repeated, but if we look at I is repeated 4 times. So we would have to divide 11 factorial by a 4 factorial, 4 for 4 repetitions of I. Check again, is there any other alphabets which is repeated? Yes, and S is also repeated 4 times. So you would have to further divide this by a 4 factorial again. Again, any other repetitions? Yes, there is a P also which is repeated twice. So divide this further by 2 factorial. No other repetitions are left. So the answer is going to be 11 factorial by 4 factorial divided by 4 factorial by 2 factorial. One should understand why do we do this division process. So let's understand the logic of it with a smaller word. Let's take the word India. Now, when I do 5 factorial, why 5 factorial? 1, 2, 3, 4, 5. Now 5 factorial is an answer for arranging 5 distinct objects in 5 positions. So what I am considering is the 2 I's, I have considered them to be distinct. So I'll just mark them as I1 and I2. So in this 120 ways that I have counted, there are many of them. So let's see, one particular one, let's say the word India itself, I-N-D-I-A. I have counted it, treated the I's differently. So I have counted I1, ND, I2A as one possibility. Keeping the positions of N, D and A same, I would definitely have another arrangement where the I's have been interchanged. I would have counted I2, ND, I1A as another possibility. But I see that both of them refer to just one possibility, that is INDIA. And this is true for any arrangement. For example, another one could have been NDA, I1, I2. There would definitely be another possibility where the N, D and A are at the same positions, but only the I1 and I2 have been interchanged, and I would have counted this as 2 different words, whereas both of them result in only one word, that is NDAII. So to get my correct answer, I would have to do that 5 factorial divided by 2 factorial. Hope you get the logic. And if there are multiple repetition, the logic remains the same. So a little larger word with a little more repetitions. For example, let's take the word recuperate. Recuperate. Now if you look at this, I have an R and I again have another R. So let's take them as distinct R1 and R2. E is repeated once, twice, thrice. E1, C is not repeated, U no, P no, A and T not. So the R1s we have already seen. So if I take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factorial, I know there is a repetition in R, so I divided by 2 factorial based upon the last logic. Having done this, I have accounted for the fact that the R's are identical. However, I have still left the E's to be distinct. For example, let's say I have a word which is R, C, U, P and another R and an A and a T, I still have 3 E's which have been treated separately. E1, E2. Keeping the position 1, 2, 3, 4, 5, 6, 7 and 3, 10. Keeping the positions of the others other than E identical. How many different words would there have been considering the E's to be different? There are 3 E's, so I could have arranged them in 3 factorial different ways, right? E2, E1, E3, or an E2, E3, E1, E3, E2, E1, and as well as lastly E3, E1, E2. All these would actually be just one word. So I would have to take this, and to get my correct answer, I would have to further divide it by 3 factorial ways. Hope you get the logic of it. So this is just to know why and what we are doing. Also, this process of double counting or triple counting and then correcting can be useful when we do combination questions as such. We'll do just one other example in this, otherwise questions are pretty standard, and this is in how many ways can I say arrange the letters of the word engineering Let's say one question such that all vowels are together. So conditions that we have learned previously, some things being together, could be asked with these questions as well. Let's separate out the vowels. So E is an vowel, N not a vowel, G not I is a vowel, so keep it out over here. There's an N, there are 2 E's out, there's an R, there's an I, and there's an N and a G. All these vowels have to be together, so I'll just consider them as one entity. 1, 2, 3, 4, 5, 6, 7. So basically I'm arranging 7 factorial. However, many students just leave it at this point. Remember, there are some identical ones among these 7 also. So there's an N, N and an N. So I would have to divide it by 3 factorial. There's a G and another G. So I would have to divide it further by 2 factorial. First do the correct arrangement of these 7 objects. Having done this for each of these arrangements, this is not a single object, but these are 5 of them. All they are clubbed together. These 5 can arrange among themselves. In how many ways can that be? Again, 5 factorial, but 5 factorial is valid for 5 different objects. Here, do we have some identical? Yes, 3 of them are identical and the other 2 are as well identical in this case. So we would divide it by 3 factorial and 2 factorial. If the question had been arrange them in such a way, arrange letters of the word engineering in such a way that all E's are together and let's say all N's are also together. All N's are together. So the E's have to be together, the N's have to be together. So again, separating them out, there's an E, there's another E and a third E. Consider them as one entity. There's an N second and the third N. Consider these as a single entity. So I'm left with an E, I'm left with a G and an I. N is gone, R, I and a G. 3 and 3, 6, 7, 8, 9, 10, 11. They take care of all the letters. 11. This is one object, a second object. Third, fourth, fifth, sixth, seventh. So again we have an 7 factorial. Are any of these 7 identical? These are groups. They cannot be identical to anyone. But do we still have a 2 G's? Yes. And do I have 2 I's as well? Yes. So I would be dividing this. Having done this, let's go further. Let's focus on the clubbed group. There are 3 of them. It should be common sense now. Does it make any sense to arrange the 3 of them? Whichever way you arrange, they are together. They will read as E in any sense, right? Even if we go mathematically, arrange the 3 objects considered different. but they are similar, so again divided by 3 factorial results into 1 being the same answer, right? Similarly for the 3n's is going to be 3 factorial by 3 factorial. If one is fast or so on, we could even ignore these and say that the answer is just going to be this. The others are going to be one way itself in that case, right? So this is all to do with arranging words.